Hi everyone, today I'd like to talk about programming with data using data from XML, JSON, and HTML. In today's internet world, interchange of data is getting more and more important. Buying funds are transferred between banks every day. Credit records are transferred between lenders and credit bureaus. Analysts scrape data from the web for data and use data for analysis. In order for data to be transferred and received, data have to be in some standard format. And here we talked about XML and JSON. XML stands for Extensible Markup Language, and JSON stands for JavaScript Object Notation. Both standards are commonly used nowadays in practice. XML came first and has been out there for use for a while, which I mean a very long time. It was used between websites for data transfer, between website and applications for data consuming. For example, we can write an application that query XML data and stores the data in a database. JSON came later using JavaScript syntax, and it becomes more and more popular for representing data in web applications and also web services. Nowadays, most programming languages have libraries for parsing and generating XML and JSON data. The parser reads and converts XML or JSON data to a tree data structure. The tree is usually called the Document Object Model, or in short, DOM. And later on, analysts can traverse the DOM model to extract the data that is needed. Many of us have been familiar with hypertext markup language, or in short, HTML. The primary purpose of using HTML is to present data in a browser. XML, however, is stricter in format than HTML, and it is used to represent data. With HTML tags, we cannot define our own tags. If you look at the source of a HTML page, you can see tags are like HTML, head, body, table, TD, TR, etc. They are defined in the HTML specification. We cannot add more tags of our own in there. However, HTML is for formatting documents, so this is not a problem. HTML, on the other hand, is however used to define data, and it allows us to create our own tags. Now let's look at an example of XML data. After the first row defining the XML version, we can see the element, namely actress. This element is a parent of a number of child elements. Child elements are, as you can see, include name, age, address, city, state, zip, and country. Each element has a starting tag and an ending tag. For example, name is a starting tag and the other is the ending tag. The difference between the ending tag and the starting tag is a slash. Could we convert this record to JSON format? If we do so, then each attribute and tag could become a property. This is the equivalent JSON data. We can see that strings must be quoted. Properties or field names must be quoted also. Other types that are supported include number, string, boolean, array, object, and noun. In JSON data, objects are delimited by the curly braces with comma-separated properties. In the example, we can see the properties name, age, and alive are separated by commas. Arrays are delimited by the square brackets with comma separated elements in between. For example, in this array, we have elements such as testing 1, 2, 3, and GPA. Going back to the same example, assuming that we have movie text that define movies, and we add two movie elements. One is for desert blue and another is for bright wars. Converting to JSON, we have a property and we use an array to store the movies. Now talking more about the structure of XML data. We have talked about tags. A tag may be a start tag or an end tag. An element is the section of data beginning with a start tag and ending with the matching end tag. Elements must be properly nested. So let's look at the example. We have the course element, which is a parent of title. So title for both the start tag and the end tags must be inside the start and the end tag for course. There may be multiple course elements, as we can see here. And those elements are the children of the catalog element. In each document, there would be a single top level element. Now we talked about attributes. Elements can have attributes. For example, the course element has course ID as an attribute. Math 1131Q is the value of the attribute. Attributes are specified by name value pairs inside the starting tag of the element, as we can see. So course ID is the name of the attribute and math 1131Q is the value of the attribute. An element may have several attributes, but each can only occur once. In this example, we can see we have two attributes, course ID and credits. Now we talked about namespace. When we exchange data using XML between organizations, a tag in one organization may mean differently in the other organization, which may cause confusion. So the solution here is to use a unique name just before the element name. For example, Yukon course ID. So if we receive data from another university, for example UCLA, then UCLA would be the unique name in front of course ID. For courses from UCLA, we have UCLA colon course ID, and for Yukon courses, we have Yukon colon course ID. With namespaces, it allows to avoid using long names. In the example below, we can see instead of having just course ID, title, department name, credit, we have the unique name Yukon and colon in front. So this is a good thing. It allows us to define data for different institutions in the same document. In order to do so, we need to define a namespace for the prefix. The namespace is defined by using the XML NS. XML NS. NS is for namespace. So we use XML NS attribute in the start tag of an element. The namespace declaration has the syntax XML NS for namespace, colon, and then prefix, followed by the equal sign, and then a universal resource identifier. In the example, we can see Yukon is prefixed, and the URI, which is a universal resource identifier, is http www.yukon.edu. Next, we talked about XPath. XPath is a query language for selecting nodes from an XML document. An XML document is treated as a tree of nodes. The element on the top, the topmost one, is called the root element. Looking at the example, we can see catalog is a root element. Note that everything in an XML document is a node, including elements, attributes, text, and comments. There are parents and child nodes. In the example, we see title, department, and credits are children. Of course, we have sibling nodes. In the example, we have title, department, credits as siblings of each other. We have ancestors and descendants. Looking at the example, catalog and course are ancestors of title, department, and credit. Or also we can say title, credits, and department are descendants of the others. So how can we query data using XPath? In the expression column, we have the query, and on the right side we have the description. If we write just the node name, it means that we select all the nodes with the name as indicated in the node name. If we have the /, it means we select from the root node. If we have the double /, it means that we select nodes from the current node that matches the selection, and it doesn't matter where they are. The dot is to mean we select the current node, and the double dot is to mean to select the parent of the current node, very much like when we traverse between levels of directories. And finally, the add letter, very much like in your email address, is to select attributes. Now let's look at a few examples. From the XML document that we saw previously, if we write catalog, that would mean to select all the nodes with the name catalog. If you write / catalog, that would mean select the root element catalog. If you write catalog / course, that would mean select all the course elements that are children of catalog element. If we write double / course, that would mean we will select all the course elements in the document. If we write catalog / and course, that means we select all the course elements that are descendant of the catalog element. If we instead write title instead of course, then we would select all the title elements that are descendant of the catalog element. And finally, we write double slashes At course ID, here we select all the attributes that are named course ID. This is a real example. The link gives the daily treasury view curve rate data. If we change the name, I mean the year, instead of 2017, we write 2020 or 2019. We have the corresponding data in that year. In the data, we can see the entry node is the parent of many other nodes. And there are many entries. The letter D here is the prefix that we have talked about with namespaces. And we are querying for the tag BC 3 months. We can see we have the start tag and the end tag, and we also have the value, which is 0.53. Once we have a tree structure, we can use XPath in order to query data. So we query for BC 3 months. We query for BC 3 months elements, no matter where they are in the current node. In this specific example, we also need to put in the universal resource identifier that we had, or actually the XML document contained in the namespace. This is because there are multiple namespaces. How about JSON data? Let's also take a real example. Querying for the symbol MSFT, which is a stock symbol for Microsoft, and we query time series daily from this website alphavantage.core. Looking at the format of the data, we can see that this is a dictionary. Metadata is the key, followed by its value. And this value is actually a dictionary also. So if we get the data, which is a dictionary, and we give it the key, then we get the value of metadata, which is a dictionary. And this one, right? Then if we would access to any field in that dictionary, we give it the key. So if we'd like to access to symbol, the key is number 2 dot symbol. Then we give 2 dot symbol as the key to data metadata. And what we get is the value of 2 dot symbol, which is MSFT, the symbol for Microsoft stock. If we would like to access to another key, which is time series daily, time series daily is the second key in the dictionary, followed by its value. And its value is actually a dictionary also, starting from here, the open curly brace. So if we write data and give it the key time series daily, we get the dictionary. And if we want to access to a specific day in that dictionary, then consider data time series daily as the dictionary. Then by giving the key 2020 02/14. We get all the data corresponding to that day, as we can see here, right? Time series daily, which is the key. Then we get the data starting from here until the end of the dictionary somewhere. And we access to that specific day. We get all the data corresponding to that day, starting from here. Until the closing curly brace. And note that the data for that specific day is also a dictionary. We can continue following that same method to get to open, high, low, and close braces, and also volume. So we talked about how to get data, pass data in XML and JSON format. How about HTML? Data can be read from HTML in a similar way. There is also another way which is very much more advanced people who know more about HTML. This method controls the WebDriver directly, so you can programmatically click buttons, send keys, etc. just like a human. We will need to find class. Class here is a property of a tag, HTML tag, that tells the browser how to present the tag on the browser. If the tags have ID or name attributes, those are useful as well, and actually more useful. We can also, based on some characteristics of elements that store data. Here I show you how to analyze data on a website using Chrome. In Chrome, when you open a website that you want to analyze, click the three dot button right here. That opens up the menu. Then you select More Tools and select Developer Tools. Note that there are similar tools in other browsers such as IE, such as Firefox, Edge, etc. Okay, once you do that, we can see the source code on the right side, and the web page is still on the left side. Then click the arrow, then hover the mouse on the element which you want to inspect. For example, the description of this product. When you click it, it will show the corresponding path in the source code. Now here, after you click the description of the product, the right side shows exactly the path of the source code that define that description. We have div. This tag defines an area on the browser for this description. The attribute class is underscore 3WU53N, which define how the description is displayed. For example, in terms of font, in terms of bold, being bold or italic, etc. In this example, I assume that only this div at this level uses this class. So I'd like to use XPath to query all the div tag that has this same class attribute and value. Then in my XPath, I would write the name of the tag, which is div, and within the curly brackets, I write the name of the attribute, which is class, and equal, and the value of the class that I'd like to query. And I'd like to return the text of the div tag, and I'd like to return all such div elements. And that's where I use the double slash. Then you will see more when you go to the notebook and practice.